Evening friends, today again I am back to talk on the topic of the engineering economics, and in this lecture we are going to talk about the last bit of the compound interest problem, that is uniform gradient series annual equivalent amount. Okay, so let's go with that. Okay, uniform gradient series. Okay, basically in this we are going to find the annual equivalent amount. Okay, annual equivalent amount, it is given as a is equal to a1 plus g. Okay, a g I and that this is the annual equivalent amount. This we are not knowing. Okay, so I have written it here in the top. Further g, that annual increment that we are knowing. Okay, the cash flow diagram is given by, okay, in this way. Okay, this is a1 is your first installment. Okay, means that every year you are going to invest equal amount. Okay, this is fixed. Okay, further g, that from the next onwards year. Okay, so sorry, it is 2. Okay, 3 4, from next onwards year equal amount of g that you are going to increase. Okay, till n years. Okay, so that is g is your successive installment that is going to increase every year. Okay, so basically here we are going to find the equivalent amount. Okay, what is an annual equivalent amount? Okay, to find that we are having the formula a equal to a1 g, and this further interest rate and the number of years. Okay, positive sign we have to deal with for the increment, and negative sign for the decrement. Okay, so better let's solve one of the problem so we can easily understand it. Okay, let's move to the problem. Okay, here it is saying that a person wants to gift car to his daughter when she would turn to 18 years. Okay, 6 years from now, means that she is now of 12 years. Okay, see, he decides to put away money in her name during her next 6th birthday. Okay, he wants to deposit of rupees 25,000 in the first year and go on increasing by rupees 5,000 every year. Okay, for the next 6 year. Means that here that a1 first installment, that is 25,000, that is fixed. Okay, that in each year he had to pay, he is going to pay 25,000 plus from the next onwards year. He is saying that in the first year, and from around increasing it by 5,000 every year. Okay, for the next 6 year. For the next year he is going to increase an amount of 5,000. So in the next year 5,000, again next year 2 into 5,000, again next year 3 into 5,000 till 6 year. Okay, further he is saying that if he estimates that in a car would cost rupees 5 lakh. Okay, when he wants to buy one. Okay, how much more money should be added to the maturity amount that he receives from the bank. Okay, if it is assumed to grow at an interest rate of compounded annually. Interest rate they had given. Okay, so right, then what they have given. Okay, present amount they had given, that in equal installment. Okay, a1 they had given 25,000. Okay, 25,000, further go on increasing by 5,000. So they had given g as a 5,000. Okay, further they had given for time year 6 year, n is 6 year. If he estimate that in a car would cost rupees 5 lakh. Okay, he is assuming that in the future after 6 years the car cost would be 5 lakh. Okay, when he wants to buy one. Okay, how much money should be added to the maturity amount that he received from the bank. Okay, if it is assumed to grow 11.5% and compounded annually, interest that given 11.5% and compounded annually. Okay, so first draw the cash flow diagram. Okay, a1 plus g, okay, a1 plus 2g, okay, up to 6 year, n equal to 6 year, that is a1 plus 5g. Okay, so we are having, now we are going to find an equivalent amount. Okay, that formula is a1 plus g, a by g, I and n. Okay, a1 plus g, okay, formula is 1 plus I to the power n minus in minus 1 divided by I, 1 plus I to the power n minus I. Okay, now substitute this value. a1 is your 25,000 plus g is your 5,000, okay, 1 plus I is 11.5%, okay, interest rate, so 0.115 to the power n for 6 year. Okay, 6 minus 0.115 into 6 minus 1, okay, divided by 0.115 interest rate plus 1 plus 0.115 to the power n 6, okay, minus 0.1555. Okay, if you will solve this, you will get the annual equivalent amount of rupees 35,924. okay, this much annual amount you need to get. Okay, further he had said in question that if he estimated that in a car would be of 5 lakh, okay, in a future amount, okay, future amount is 5 lakh of the car, okay, how much more money should be added to the maturity amount? Okay, so first after this you need to find in a future amount. Okay, that future amount formula, now we are knowing in a present amount. Okay, sorry, annual amount we are knowing. Okay, now further if you will draw in a cash flow diagram, you will get, okay, cash flow diagram AA. Okay, this is 6, this future amount you are going to know that. Okay, find that. Okay, A you got value, okay, interest is your 11.5%, A is your 35924. Okay, and we need to find in a future amount. We know the formula for that. F is equal to A 1 plus I to the power n minus 1 upon I. Okay, so put this value here. F is equal to A 1 plus I is 0.115 to the power n minus 1, n is a 6 year, divided by I 0.115. Okay, if you will solve this, so A is your 35,924. Okay, if you will solve this, you will get in a future amount of 287,872. Okay, this much future amount you are going to get. Okay, but what you have assumed in the question, he said that person has assumed that car cost would be 5 lakh. Okay, So subtract this value from that. Okay, car cost right here, car cost equal to rupees 5 lakh. Okay, and you are having in your bank is going to pay you 2,87,872. Okay, to be paid by bank, equal to 287,872. Okay, so what additionally amount that you have to add at that time after 8 years? Okay, so amount to be added, additional amount. Additional amount what to be added, you have to subtract that 510 raised 5, okay, minus 287,872. Okay, after subtracting you will get the value of 212,127. Okay, okay, so in the question they said, here asking in the question that how much money more, how much more money should be added. Okay, so this much amount of the money to be added after 8 years, okay, to get the new car. Okay, these are required answer. Okay, I hope you enjoyed this. This completes our first unit. Okay, go for the other different types of the problem from the textbook, so you will easily understand that. Okay, thank you very much for that.